So good morning to all of you. In this video I am going to discuss the Coulomb's law and how to solve the problem with the help of Coulomb's law. So what is Coulomb's law? Coulomb's law states that if we have a two-point charges which are separated at a distance r, let's say this is q1 and this is q2, which are separated by a distance r, then the force between these two charges, force is directly proportional to product of discharges and inversely proportional to 1 by r square. So if we combine, so we have q1 q2 by r square, and if we replace the proportionality, we will have a constant k q1 q2 by r square, and the value of this k is 1 upon 4 pi epsilon 0 q1 q2 by r square. So this f is a vector quantity, so its direction is r hat, and the value of this 1 by 4 pi epsilon 0 is, the value of this entity is 9 into 10 to the power 9. So this is this much Newton. So this is the mathematical form of Coulomb's law, where epsilon 0 is a free space, where epsilon 0 is free space permittivity, permittivity. Its value is 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square, and the value of 1 by 4 pi epsilon 0 is 9 into 10 to the power 9 Newton meter square per Coulomb square. So F is attractive. This force F is attractive. If q1 and q2 have opposite sign, and this is repulsive if this q1 and q2 have same sign. So this is the way to understand the Coulomb's law, which states that the force of attraction between these two-point charges is directly proportional to the product of charges and inversely proportional to the square of distance. Now its validity and its applications. So Coulomb's law is valid for our limitation. What is the limitation of Coulomb's law? So Coulomb's law limitation. First limitation is, it is valid for point charge. Valid for point charge. 1. Cannot use, and it is difficult to apply any arbitrary shape charges, because for arbitrary shape charges the distance between the charges are different. So therefore it is not valid for arbitrary shape charge. It is only valid for point charge. Applications. So we can calculate, using Coulomb's law, we can calculate the distance and force between 2 point charges, And another application we can also distance with, and the first application we can calculate the distance and force between two point charges. Second, we can calculate electric field because we know F equal to E equal to F by Q. So we can calculate, let me write here. So it has two applications. The first one is we can calculate the distance and force between point charges. Second, we can also calculate the electric field, which is electric field E equal to F by Q. So this is the applications. Next we will discuss about how to deal with the Coulomb's law in order to find out the charges, forces and distance between the charges. So we will solve few examples based on the Coulomb's law. The first example is calculate the force between two charged spheres containing charges. So, example, calculate the force between two charged spheres containing charges two into 10 to the power minus 7 Coulomb and 4 into 10 to the power minus 7 Coulomb. When they are kept at a distance, they are kept at a distance 3 centimeter. So what we have? We have two charges whose magnitude is given as. So we know the Coulomb's law. We know the Coulomb's law. F equal to 1 upon 4 pi epsilon 0 Q1 Q2 by R square R. So given that from this problem what we have? We have given that two charges, Q1 is 2 into 10 to the power minus 7 Coulomb, Q2 is 4 into 10 to the power minus 7 Coulomb, and distance R is 30 centimeter, which is in CGS system. Since our this is MKS system, so we have to convert this 30 centimeter into 1 in MKS system. So now we know the value of 1 upon 4 pi epsilon 0. So now putting the value of Q1, Q2 and R in order to find out the force. So with the help of Coulomb's law, we can evaluate the force between two charged spheres. So its value is 9 into 10 to the power 9. Q1 is this much, 2 into 10 to the power minus 7, and Q2 is 4 into 10 to the power minus 7 Coulomb divided by 0.3 meter. So this becomes 9 into 10 to the power 9 into 8 into 10 to the power minus 14, minus 7 becomes 14, and this is 0.09. So this can be written as 9 into 10 to the power minus 2. So this 9 will cancel out, and what we have, 8 into 10 to the power 8 into 10 to the power, this is minus 2, this becomes 11. Okay, so this is 11 into 10 to the power minus 14. So we have 8 into 10 to the power minus 3 Newton. So this force, since the charge is, what is the nature of force? This F is 8 into 10 to the power minus 3 Newton. And what is the nature of whether this force is attractive or repulsive? So in this case, this is repulsive force. Why it is repulsive? Because it depends upon the nature of charges. So in this case, our Q1, Q2 are of same sign. Both the charges are positive charge, same sign. That's why this force is repulsive. And this is the way to find out the force for a given charge and separation distance. Thank you.